Give a little bit of your time to me. Give a little bit, I'll give a little bit of my time for you. There's so much we need to share, so we'll take some time and show you care. Hey everybody, welcome to this week's edition of Video Notes for Mr. Flugum's General Chem class. That's right, this is for Gen Chem. And just so you know, these notes will go on page number 24 in your notebook. Thanks for tuning in, you guys. Let's go ahead and get started. Alright, so as we're talking about electrons, we need to know this, okay? Electrons are organized into what are called energy levels. And those energy levels are located around the nucleus. Remember, that area around the nucleus is called the electron cloud, right? And the electron cloud is organized into energy levels. Now, within these energy levels, the higher the energy level, the farther we are from the nucleus, right? Okay. And there are at least 7 energy levels. Now, you can maybe go higher than that and make some arguments about that, but there's about 7 energy levels. And N represents the energy level number. Now, I didn't mention this one up here, I know that, but it's just kind of a point of emphasis that even though these electrons are kind of organized and they have energy levels and things like that, we can't really find the speed and location of electron at the same time. We can either know the speed or we can know the location, but we can't know both at the same moment in time, which means electrons are quite random and unpredictable. However, they are still organized. Now, each of these levels has a maximum number of electrons. Okay, remember the N here means the energy level, right? So when N equals 1, we can hold up to 2 electrons. Okay, that's the first energy level, right? That holds 2 electrons. Okay, when N equals 2, we can hold 8 electrons. Okay, when N equals 3, we can hold up to 18 electrons. Okay, so you notice as we get farther and farther from the nucleus, we obviously get bigger and bigger spheres of electrons that can be fit in there, right? When N equals 4, we can go all the way up to 32 electrons. Okay, and then that's about as big as we get. Okay, sorry about the capital N there, that should be a lowercase n. Groups 5, energy levels 5 through 7 can also only hold up to 32 electrons. So there is kind of a maximum point that we get to with electrons, all right? But you can see here as we go out, they get larger and larger until we get to N equals 4. And just one more thing with energy levels, when we're filling them up, right, when an atom is kind of growing or we're building their electron structure, we start at the beginning. So when we fill up N equals 1, we fill up level 1, then we begin filling level 2. When level 2 is full, we begin filling level 3, and so on. So we always fill from the lowest energy level up until we have enough electrons in order to fill an atom out. Okay, so let's talk about a Bohr model, which kind of represents for us electron energy levels. Okay, you can see right here, this is a calcium atom. Okay, it's a Bohr model of a calcium atom. It has 20 protons, 20 neutrons. Okay, and if you count all the dots there, there are 20 electrons. Okay, all arranged by level. If you notice, there's 2 in the first level, and then 8, and so on. Now you might be saying to me, why did you get to the level 4 and only have 2 out there? Well, we will address that another day in class when I can try and explain it to you and not make it so confusing. Okay, so let's do this. Let's draw a Bohr model of oxygen. So here we go. Alright, here's our nucleus. Oxygen is element number 8, so we have 8 protons, we have 8 neutrons. Okay, there's our nucleus. All right, now we're going to do this. We're going to go energy level 1, right? N equals 1. And that can hold 2 electrons on it. I like to use E's for my electrons. Doesn't really matter. Okay, so there's 2. And then there's 8 electrons altogether, right? However, that first level is full, right? So we need to put the next electrons on the second level. So there's 1, 2, 3, 4, 5, 6. Now if we count all of our electrons, right, we have 1, 2, 3, 4, 5, 6, 7, 8. That's 8 electrons for an oxygen atom, right? You can see we have 2 here on the first level and 6 on the second. And that is all the electrons that we need. Now, as we look at these Bohr models, I want you to understand some issues with them. There are some good things and there are some problems. So let's start with the problems first. Okay, the problem is this. It is not an accurate representation of what the atom actually looks like. Okay, we need to understand this for sure. Electrons do not orbit like planets. Okay, the nucleus is not the sun and the electrons are not organized like planets orbiting around it. Okay, those electrons are just arranged into energy levels. Some tend to be closer to the nucleus, because they have a lower energy. Some tend to be farther away, so they tend to have a higher energy. All right. Now there are some good things about Bohr models, though. Okay, they help us represent electron energy levels, which tells us a lot about how an atom is going to act. It also does this, right? It identifies electrons in the highest energy level. So we can see here with our calcium atom, right, that there are 2 electrons here in the highest energy level. Those are important electrons. All right, so here's kind of the last thing I'll talk about with you, and that is this, valence electrons. All right, so valence electrons, you can see the definition there, right, are electrons in the highest energy level of an atom. That means this, they're farthest from the nucleus, all right, they have the most energy, which means they're the least stable, right? And they are the easiest for that atom to lose or share. All right, it's going to keep those lower energy electrons close to the nucleus, but the ones in the valence, right, the valence electrons are going to be the ones that interact with other atoms. And this tells us a lot about how elements behave, right? So that means how reactive are they, what other elements will they combine with, and in what ratios they will combine. So valence electrons are very important. Now this here is a carbon atom. All right, 6 protons and 6 neutrons there in the center, right there. Okay, and we have 2 electrons, right, in the first level. And then here are our valence electrons. There's 1, 2, 3, 4 valence electrons in the second level. So valence electrons are very, very important. We'll be talking more about that. Well, thanks for tuning in, you guys. I appreciate your time, and I will see you in class on Thursday or on Monday, whenever you need to get this video done. Hope you have a great day. See you later. Bye-bye.